Have you ever wondered how blockchain works, or even what is blockchain? Well, let's delve right into it. At its core, a blockchain is a type of database, but what sets it apart from your run-of-the-mill databases? It's all about the structure of data storage. Think of a regular database as a giant spreadsheet, where data is stored in columns and rows. It's efficient, sure, but it's not the most secure. Now imagine a blockchain as a series of interconnected blocks, each containing data. Instead of rows and columns, data in a blockchain is stored in these blocks that are connected, forming a chain. This structure makes it incredibly difficult to alter or manipulate data once it's been recorded. So it's not just a database, it's a new kind of database, one that's robust, secure, and extremely difficult to tamper with. So in essence, blockchain is a unique type of database with its own special way of storing data. Now that we know what a blockchain is, let's delve a bit deeper and understand its workings. Imagine that you've just completed a transaction. Maybe you've bought a coffee or sold a book online. That transaction is bundled with others into a block. A block, in the simplest of terms, is a collection of these transactions. Each transaction in the block is like a line item in a ledger, detailing who sent what to whom. Now this block doesn't just float around aimlessly, it's added to a chain of previous blocks, hence the term blockchain. Each block is linked to the one before it and after it, creating an unbroken and unbreakable chain. But here's the interesting part. Before a block can be added to the chain, it needs to be verified. The computers in the blockchain network, often referred to as nodes, come into play here. They confirm the details of the transactions, making sure everything is legit. Once a block is filled with transactions and it's verified and approved, it's added to the chain. And once it's in the chain, there's no going back. It's like writing in permanent marker. The information is stored, secured, and linked to the rest of the chain. This process of storing transactions in blocks and adding them to the chain happens over and over, creating a long, secure, and transparent record of all transactions. If you think about it, it's a rather elegant solution to the problem of keeping track of transactions in a digital world. So in essence, a blockchain is a continuously growing list of records called blocks, which are linked and secured using cryptography. Each block typically contains a cryptographic hash of the previous block, a timestamp, and transaction data. Think of it as a digital ledger of transactions that is duplicated and distributed across an entire network of computer systems on the blockchain. And there you have it, a deeper understanding of the inner workings of blockchain. The next time you hear about a blockchain transaction, you'll know exactly what's going on behind the scenes. One of the key concepts that make blockchain unique is decentralization. But what does it really mean? Imagine a library. In a traditional library, there's a librarian who keeps the records of all the books, who borrowed them, and when they are due back. This librarian is a centralized authority. Now think of a blockchain as a library too, but with a twist. In this library, there isn't just one librarian, but everyone who comes in becomes a librarian. Each one has a complete record of all the books, who has them, and when they're due back. This, folks, is decentralization in a nutshell. In the world of blockchain, instead of a single entity like a bank or a government, every participant or node has a copy of the entire blockchain. Each transaction is recorded on every participant's copy. This means there is no single point of failure, no central authority that can be compromised. Additionally, each transaction is verified by a consensus mechanism. This requires the majority of nodes to agree that a transaction is valid before it is recorded on the blockchain. This process ensures the integrity and security of the entire system. So, why is this important? Well, decentralization in blockchain brings about a few key advantages. First, it increases security. With no central point of failure, it's much harder for malicious actors to attack or manipulate the system. Second, it enhances transparency. Every participant can see every transaction, which helps to promote trust and accountability. Lastly, it distributes power. In a centralized system, one entity has control. In a decentralized system like blockchain, control is spread across the network. Each participant has an equal say in the functioning of the system. This decentralization is what makes blockchain such a revolutionary technology. It has the potential to transform industries and societal structures from finance to healthcare, from governance to supply chains by making them more secure, transparent, and democratic. In other words, blockchain is a democratic system where every participant has an equal say. You might be wondering, with so many participants and no central authority, how does a blockchain maintain security and transparency? Well, let's dive right into that. Firstly, we have to understand the role of miners in the blockchain network. Miners are essentially the backbone of blockchain. They are responsible for validating new transactions and recording them on the global ledger, also known as the blockchain. This process, known as mining, is no easy feat. It involves solving complex mathematical problems, which requires a significant amount of computational power. But what does this mining process achieve? Every time a miner solves a problem, they create a new block. This block contains the latest transactions, which are now confirmed as legitimate. The miner then adds this block to the blockchain, which is visible to all participants. This is where the concept of transparency comes in. Because each transaction is recorded on the blockchain and the blockchain is available to all participants, it's virtually impossible to make a fraudulent transaction. If someone were to attempt it, it would be immediately noticeable and could be easily traced back to the source. This level of transparency is unprecedented in traditional financial systems. Now let's talk about security. Each block in the blockchain is linked to the one before it through a unique code called a hash. Changing information in a block would change its hash, breaking the link with the next block. To successfully alter a transaction, a fraudster would need to change the information in all subsequent blocks at nearly the same time, which is computationally impossible. Moreover, the blockchain network operates on a consensus protocol. This means that before a transaction is added to the blockchain, the majority of the network's participants have to agree that it is valid. This further enhances the security of the blockchain, making it resilient to attacks. Therefore, the security and transparency in blockchain are maintained through complex mathematical algorithms and a consensus protocol. This combination of security and transparency is what makes blockchain such a powerful and revolutionary technology. Blockchain is not just about cryptocurrencies. Its potential applications are vast and varied. While it's true that blockchain technology is the driving force behind cryptocurrencies like Bitcoin and Ethereum, it would be a mistake to limit our understanding of blockchain to just digital currencies. So, let's broaden our horizons and explore how this revolutionary technology is being applied in various sectors. First, let's take the finance industry. Blockchain is changing the game by enabling faster and more secure transactions. For instance, international remittances that usually take days can be accomplished in a matter of minutes, thanks to the blockchain's ability to bypass traditional banking systems. Next, supply chain management. Blockchain can provide an immutable and transparent record of a product's journey from the source to the consumer. This means we can track a coffee bean's journey from a farm in Colombia to a Starbucks in New York, ensuring ethical sourcing and reducing fraud. Now, let's talk about healthcare. Blockchain can provide a secure and decentralized framework for patient data. This means your medical records could be stored in a way that guarantees privacy and accessibility, with you, the patient, in control of who can access your data. Furthermore, blockchain can also be applied in voting systems. By creating a transparent and tamper-proof system, we can ensure that every vote is counted correctly, potentially revolutionizing the way we conduct elections. And these are just a few examples. From energy trading to intellectual property rights, from real estate transactions to peer-to-peer lending, blockchain technology is finding its way into every corner of our lives. So while blockchain might have started with cryptocurrencies like Bitcoin, its potential applications are only limited by our imagination. Let's quickly recap what we've learned about blockchain. We kicked off by defining blockchain as a continuously growing list of records, or blocks, linked and secured using cryptography. It's a digital ledger of transactions that's duplicated and distributed across the network of computer systems on the blockchain. We then delved into the concept of decentralization, highlighting how it eliminates the need for a central authority and promotes peer-to-peer interactions. We also touched upon the robust security and unprecedented transparency offered by blockchain technology, making it nearly impossible to alter past transaction data. We wrapped up with a look at the wide-ranging applications of blockchain, from finance and healthcare to supply chain management and beyond. Blockchain has the potential to disrupt various industries by enhancing efficiency, security, and transparency. And that, in a nutshell, is the fascinating world of blockchain. A revolutionary technology that promises to transform how we conduct transactions and manage data.